GPLHOW2H. Okay, this one we're going to start off with the sound table program, which is what I called it on the disk. This is the sound data table creator. I showed you from the last video. Not many people downloaded it, so I'll show it to you again. Now, I didn't do simultaneous sounds because I didn't know what I was doing yet, so this time I do. I'm going to put in a sound. It's going to be call sound 400, 330, 131. So it's basically two simultaneous sounds, channel 1 and channel 2, or I should say on the sound generator 1, sound generator 2. And the data it prints out is going to be 038315911800. The 03 is the number of bytes. That would be the 3 following bytes. The last byte is going to be our volume, and the 00 at the end ends the sound data. So I have to do two of them. I have to do the first one on channel 1, or sound generator 1, and the second one on generator 2, which is why you see the second one say 400. So 400 is the time that it takes to do it in milliseconds. The 131 is the frequency. The volume is 6. And it kicks out the data 03, A6, 35, B3, 18, 0. Now, this is in hexadecimal, of course, because that's what GPL uses, or assembly. So what I'm typing out right now, what you see on the bottom, is I'm typing out the two separate. I wrote one down, and then I wrote down the other one, and I'm typing them back into the screen so you can see it. Now, you have to combine them together into one statement so it'll do it simultaneously. Otherwise, it'll be like my last video, which is it does it one at a time. On this one, I took the threes, the first of the threes together. I threw away the B3 at the, the 18 at the end because it's not needed, and I put it at the very end, and I just combined the two of them. If you look it over carefully, you'll see exactly what I did. This is the corrected values as it should be. All right, now what we're going to do is we're going to load up the assembler, or we're going to load up the editor, which is the rag editor. We're going to load up the source file, which is ssounds. There's two files, ssounds and sdata. I'm going to show you what I was doing here in my variables. We have a temporary list variable here. It's just sound, which like we did in the last one. But now we've added a GPL interrupt timer in this one. So we're going to be using the interrupt timer in one of the demos. This is interesting. This is the address of GPL sound list pointer. In other words, it shows where GPL is with the address of the sound that GPL is processing. It'll do it in VDP too. Now I'm just listing down here. This demo right here, I had to load the upper and lowercase character sets, and I just wanted to show you how you do that in GPL with the assembler. You just store the values there, and then you just call upper and lowercase, and it loads the character sets. Then I'm going to go down. It's the same demo as it was before, just more letters of the alphabet in the keys that you can press. Then they do it in simultaneous sounds instead of single sounds now. I added computes, which is from computes assembly language. An explosion sound I added. And this is interesting. I got this out of the GPL manual. This is drop. This one uses the interrupt timer. And what it does, I'm showing you here that it takes the highest note there. This is going to be the VDB sound list this time. We're going to be putting this list in VDP because you can modify it in GPL, in Graham, but it doesn't work in all different types of devices. In Classic 99 it'll work, but it won't work in some devices, so I was going to use VDP instead. And then this is how it shifts and stuff like that. I explained it in the off to the sidebar on how it works. Then I'm playing it from VDP, like I said. The timer works like this. I clear the timer. It's zeroed. Then I compare it to 0. But by the time it gets to this next step here, it's not 0 anymore. It's already been incremented by assembly. So it goes to the back to the compare 0 until it finally does reach 0 again. Compares it to 200 for the value for temp. When it hits 200, it's done. I also increment the note number by 1. That's it. That's how it works. When you press the, I believe it's the U key. Yeah, U, T-U-V. It'll be the U key that'll be do that one. And then we also have the V. I've added the W, which was the pop the weasel. Then I add an X key and a Y key. Now this Y is interesting. It's going to take an address that's in the list that it's playing, and it's going to put it back in and restart it. It has some interesting applications. Now I'm going to show you S data, which is where all the data is. This took a long time to create. The reason why is because, as you can imagine, typing in all that code and then turning it from basic into bytes took a while. And then I've retested it and checked it 4, 5, 6 times to make sure that all the values are correct. And then each time here, I recombine them together to show you how you do it. Like see the 9 at the first? This is 3 separate statements that I combine to make into one. So in other words, the call sound, the first one, the second one, and the third one. Now, when we get down to the one we press V at, and it'll play that sound. There's computes right there. I copied theirs and then added an ending. This is the drop, the value for the drop one I told you about. Use the interrupt timer. Here's the explosion. You guys heard that before. It's the manual. Weasel, you've seen before. Beat is just Beethoven. Now, I'll show you here how I do it. 400, 350. If you put the two values in, you can combine them. You'll see what I did using the sound conversion table program. It's pretty easy to see what happens. Just take the two values together and then you add them together. It explains it in the Compute's Guide to Assembly Language also, which is mostly what I'm using. So there's a lot of files here, call sounds, just to show you that it can be done. It's not that hard to do. I thought heavily about making a GPL program that does this automatically from basic or extended basic. Just looks at a basic program or extended basic program, looks for the call sound, then just takes the values and plugs them in. That's the end of the songs that's playing in Beethoven. Then I also added chimes. You guys have seen this before too, and that's it. That's all the source code. Now we're going to load the assembler, which is S sounds. Object is going to be O sounds. List is going to be L sounds. LCSFPF as usual. I'll speed it up so it'll assemble this very quickly. It's not the biggest one I've given you guys yet, but it's pretty big. I don't know if you can hear my wife in the background in the kitchen working. I'll have to listen to it later to see. Okay, so we've assembled the program. Then we'll go to the GPL loader and load in object sounds, which is the name I gave it. It's on the disk that way too. It loads up the GPL and we're ready to roll. All right, we're going to start just pressing keys to show you what happens and the sounds that come out of it. As you can see, I didn't troubleshoot a lot of stuff. The reason why is because I took straight from basic over to GPL. So if you want to try to fix anything you see that's wrong with it, have a blast. We'll see you next time. Bye.